Hi, my name is Ivan Burenovic. I will present you my final project about Hbase. I will give you introduction to technology and show a small example of MR job that works with Hbase. These are the sources I used. There are a lot of materials online. Cloudera is excellent source of information. This is short history. Hbase is based on Google Big Table. Doug Cutting and Mike Caparella are creators. So, what is Hbase? My favorite definition is a key value column family store. It represents essential terms about Hbase. It is not limited only on HDFS, but that is the main implementation. The most basic unit is a cell or column. One or more cells form a row that is addressed uniquely by a row key. So row key and one cell are key value unit that is stored and retrieved through Hbase. Column family is collection of cells or columns. You may have a limited number of column families in one table, but almost unlimited number of columns, millions. You can have text like messages and metadata pictures in two different column families in the same table. So we have rows that are addressed uniquely by row key. That is only quick access to data and essential for access. It is important to remember that all rows are always sorted by their row key. A number of rows in turn form a table. Each cell may have multiple versions per row key. Access to raw data is atomic and includes any number of columns being read or written to, but there is no further guarantee or transactional feature to span multiple rows or across tables. You access or address data through table name, row key, column family, column, and timestamp. Interface is very simple. Just put, get, delete, and scan. This is a row in physical file in the picture, and it contains one row key and one cell. So if you retrieve one row with multiple columns, column system will have to read multiple physical rows. The spreadsheet model represents a classic relation model, but Hbase model is different. It's a multi-dimensional map. In bottom half, each column family is stored in separate physical files, and that is why you shouldn't have more than a couple of them in one table, two or three. Null value is not represented at all in Hbase. Square in green is how user sees the table. Just one big table, but it's really distributed over many regions. Regions are essentially contiguous ranges of rows stored together. In theory, initially there is only one region for a table, and as you start adding data to it, the system is monitoring it to ensure that you do not exceed the configured maximum size. If you exceed the limit, the region is split into two at the middle key, the row key in the middle of the region, creating two roughly equal halves. In real life, you preset the regions. The region allows for fast recovery when server fails and fine-grained load balancing, since they can be moved between servers when the load of the servers currently serving the region is under pressure, or if that server becomes unavailable because of the failure or because it's decommissioned. Here more details. We have master server that does not store data. It assigns regions to region servers. The Zookeeper is distributed coordination service. Hbase uses Zookeeper to ensure that there is only one master running to store the bootstrap location for region discovery. Read will check memstore, that's cache memory, and H file on disk. When a write is made, by default it goes into two places: the write ahead log, val, and or H log, and the memstore. Only after the change is written to and confirmed in both places, the write is considered complete. H log is used for region recovery, very important. The mem store is a write buffer where Hbase accumulates data in memory before a permanent write. Its contents are flashed to disk to format an H file when the mem store fills up. It doesn't write to an existing H file, but instead forms a new file on every flush. These files are created over time as a modification aggregated in mem stores are eventually flushed as stores files to disk. Since also files are immutable, there is no way to delete a particular value out of them, nor does it make sense to keep rewriting large star folders to remove deleted cells one by one. Instead, a tombstone marker is written which masks out the deleted information, which can be a single cell or range of cells or entire row. A scary model, but you should be able to recognize its elements. Interestingly, client access Zookeeper just once, cache all catalogs from master region servers, and after that he accesses region server directly. What if region fails? Client will certainly recognize that and retrieve catalogs again. There is also optimization to monitor for changes on region server that is accessing. This shows the logical row as a list of key values, some in the same store file, some on the other file, spanning multiple column families. I would need half an hour to explain that, so I put the whole story in the next slide if you want to read it. One interesting thing, if you are deleting the initial column value and you perform the get again, you expect the value to be gone, when in fact it still exists, but the Thompson marker is indicating that you have deleted it, but that marker is most likely stored far away from the value it bears. It still works. These models are you can use to get abstraction of each file, simple and complex. The smallest unit is a block in each file, and to find the requested data, the region server code and its underlying store instances must load the block that could potentially have the data store and scan through it. And that's exactly what scan does anyway. In other words, one get is nothing but scan for a single row. Why to use Hbase? It can solve your problems. You should not use it for problems you can use Hadoop, it's cheaper, or those for which you have to use a relation database. It's a bad decision. One good reason is that you need variable schema in each record, and you need to store terabytes of data. It's for big data. Do not use because you hate paying the BMS licenses. Filters run on server side, avoiding transfer to client. Other features, coprocessor can use expression to analyze or summarize data based on variety of operators. Counters can be read and modified in one operation. The background process of compactions keeps the number of files under control by rewriting smaller files into larger ones. Major compactions eventually compact the entire set of files into a single one, after which the flushes start adding smaller files again. This is a scientific explanation about seek versus transfer. My future application will store data from NCDC. It's basically daily, monthly, hourly weather reports and satellite images or any other kind of metadata. Data is received from weather station and they can put or insert data into Hbase in real time. It would have many inserts per second and many retrievals by key per second. It's a good model for Hbase. Here is one report with weather station name, Artesia, Donana County, date, temperatures, and so on. Most important part of design is to choose right row key, both for store and retrievers. It is critical to understand how your row key will be distributed across the region boundaries. Data needs to spread over all regions in balanced manner, and clients should be able to use key for quick retrieval. The worst key has timestamp at the beginning, because even if you have 100 servers, only one will collect data, and that could bring down whole Hbase. You don't want all clients in concert pounding on one of the table's regions. Here we can use station name as ID and the second column that's date, but name doesn't have the fixed line. You can hash the name to generate a random key that will distribute well and be shorter. But in that case, you might need to add station name in the row as a column. You can use timestamp instead of that date here, but you'll need to reverse timestamp to retrieve the most recent version of row. This format of date here is okay. Actually, smart people from NCDC already have 5 digits IDs, so we don't have to hash anything. I explain you important practice. I wrote MapReduce code to load reports in batch, and that process will benefit from distributed run. There are a lot of Hbase classes for MR. Code assigns the output format class, which is table output format class. It is provided by Hbase and allows the job to easily to write data into a table. The key and value types needed by this class is implicitly fixed to immutable bytes writable for key and writable for the value. Map method is called for every row in the input text file and sends key and put object to Hbase for processing. It's map only job. Hbase does the rest. I tried to use VM for testing, although I was able to run Hbase. I wasn't able to code that use MR. My VM has only 1 gigabyte of memory, so I used eventually Elastic MapReduce instead with large instances just in case. And I went into the master. In Hbase shell I created table with 2 column families, metrics and pictures. Weather report daily is the name of the table. There is nothing about the columns, and it won't be anything about the columns in catalogs. So basically, if you if you don't know the column names in your table, you will need to retrieve to scan the whole Hbase table to get the column names you used. I ran the job with all input parameters here. This is column names file is in the local file system. Input data is in HDFS. I checked data in Hbase shell. Data is loaded, and another thing is Hive. I will use Hive to connect to Hbase. I created cluster. It's a separate cluster. It's very important not to run anything heavy on your Hbase. If you need to do a lot of analytics, you need to export data in different cluster for analytics. You do not want to affect Hbase cluster. So to connect to Hbase, you need to add 2 libraries in Hive shell. Set up IP for Hbase Zookeeper and link to Hbase table. After that I run SQL in Hive shell, and it triggered MR job. And by the way, there is no SQL in Hbase. So that was all. Thank you.